Okay, so here's my tricky question. My tricky question here is, I have a ruler and a cloth that I rub together, and I tell you that the ruler becomes negative. And then this material is brought close to a pith ball. Then that pith ball, which you don't know the charge of, later was brought close to another pith ball whom you don't know the charge. And then that pith ball was brought close to another pith ball you don't know the charge. And the question is, what is the charge of D, the last one? So it's not that bad, you just have to work step by step. So why don't you take a look at this. Here, I'll push off to the side. Take a look at this and see if you can figure out your answer. Pause it. Pause it. Now. Okay, and now we're going to go through the answer, okay? So let's see if you got it right. Okay, so I know that the ruler became negative. Well, if it's charging by friction, rubbing, right, then this guy, actually, let's do this in red. Okay, this one we know is a negative. We know they rub, so it's by friction. And whenever you charge by friction, whatever charge one gets, the other one gets the opposite. Therefore, A became positive. Now, if A became positive and I bring it close to a charged thing, what is that thing doing? It's pulling towards it. It's attracting. Opposites attract. It must be opposite. So opposite of positive is negative. Moving along, B was negative. I brought it close to something I don't know the charge of, and wait a second, I see that it's pushing apart. So if this is negative, then this must be opposites attract, similar charges repel. So it must be also negative. And now I bring this one close to another charged pith ball, and I see that this one was negative from before, and I can see that this one is pulling towards the negative. It must be an opposite, right? Opposites attract. Therefore, D is positive. The answer is positive for D. So that's the trickiest question I can think of for charging by friction and static electricity.